All right, welcome everyone to Ocean Acidification Week 2024. I'm just waiting for people to arrive to start the session, and so we'll get started in just a minute. Let's give it a couple more minutes for people to filter through the links. All right, well, I'll start off with going through the introductory slides. So welcome to Ocean Acidification Week 2024. Thank you for joining us. My name is Rachel Hale. I'm a marine biologist based at NIWA in Aotearoa, New Zealand, and I'm the coordinator and moderator for this session, which is on co-development and encouraging community involvement in ocean acidification research and monitoring. Please note that this session is being recorded and the recordings will be available on YouTube afterwards. OA Week is presented by 4 sponsoring organisations. Firstly, GOA-ON, the Global Ocean Acidification Observing Network. Second is NOAA, the United States National Oceanic and Atmospheric Administration. Third, the IAEA OAICC, the International Atomic Energy Agency Ocean Acidification International Coordination Centre. And last but not least, the IOC UNESCO, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific and Cultural Organization. I've got some quick history of GOA-ON to go through. So GOA-ON was established in 2012 with just a handful of members. Since then, GOA-ON has grown immensely and it now has 1,200 members from 114 countries. GOA-ON also consists of 10 regional hubs, which span across continents and oceanographic regions. And throughout OA Week, we'll be hearing from most of them. If you are not a member yet, you can join GOA-ON today by visiting GOA-ON.org. Ocean Acidification Week debuted in 2020 and returned in 2021 when events and conferences were postponed due to COVID-19. Following the successful in-person symposium on the ocean in a high CO2 world in 2022 and another successful Ocean Acidification Week in 2023, GOA-ON has brought back OA Week for 2024 to maintain momentum around ocean acidification research and provide a virtual platform for the ocean acidification community to exchange their latest findings. And we're thrilled to present a wide range of ocean acidification topics and speakers from around the world. So during the presentation, all participants are in listen-only mode. You're welcome to type questions into the questions box, which can be found at the bottom of the control panel on the right-hand side of your screen. I'll be monitoring incoming questions and will pose them to our speakers during the question and answer session, which will begin immediately after the final presentation. We've got 4 presenters, well, this evening for me, but maybe morning for other people who are attending. For the discussion, you can also use the raise hand function in the toolbox at the bottom of your screen, and we will call on you to ask your question directly. So thank you everyone for tuning in from around the globe. So as I said, this session is the co-development and encouraging community involvement in ocean acidification research and monitoring. Historically, sampling and training requirements and cost-prohibitive equipment have been barriers to the wider involvement of communities in ocean acidification monitoring, but new technologies now exist to enhance these possibilities. For example, the use of smartphones as environmental analyzers and the new low-cost GOA-ON in a box kits, both of which you're about to hear about. There are many benefits of co-developing ocean acidification research and monitoring strategies with members of the public and communities, and you will hear about some of this as well. Each speaker is going to provide a 12 to 15-minute presentation, and we'll hold all questions until the end for a larger discussion as a group. So with that, we can begin with our first speaker. I would like to introduce Jian Ma, a professor at Xiamen University in China, who will be presenting on enabling citizen science-based ocean acidification observations using smartphones. Jian, if you'd like to share your screen.
Okay. Rachel, can you see the screen?
Yep.
Okay. Okay, thank you very much for the introduction. I'm Jian Ma from Xiamen University, and it's my great honor to give this presentation. I got my PhD in the same university in 2008. Then I went to US for postdocs. One is in a chemistry department, and another is in USF. You might know Bob Byrne for his work on the carbon dioxide environment. Then I came back as associate professor, then promoted to professors. So my research interest building new methods and instruments for the seawater analysis. So some professional instrument I have built is called IC. It's an integrated syringe pump-based environmental water analyzer. It's a long name, but you can remember the short one is IC. So the IC has been developed and updated to 3 generations, especially in last year. It has been commercialized by a local company in Xiamen University. And last year, we took this IC nutrient analyzer to international nutrient intercomparison research. I think Xiamen University is one of these 12 groups, and our IC is the only one lab-made instrument at that time. And for IC, it can also be used for spectrophotometric pH measurement. And this year, we just published this paper last month. We can use the IC pH for mapping the coastal seawater pH. We can also apply this for in the Arctic and Arctic. Just now, I think our IC pH system is in Snowdragon, the icebreaker in China, for the Antarctic. But they are all the professional, the scientists needed instruments. And 10 years ago, when I was a postdoc in Bob's lab, we collaborated with Dr. Bo Yang. We developed a called DIY photometer for to measure the pH, and the accuracy could be 0.01 unit. So it's a very good result for a very cheap and low-cost photometer. And on the right side, you can see the data. High benchtop spectrophotometric method. So afterwards, I think many scientists are very interested in building low-cost sensors. In 2019, Dr. Alec Wang from Hui. He wrote a review paper for the OceanOps 19, the conference. That review paper, he listed many low-cost sensors. I think for pH measurement, they have the iSemi and also 5 meter. It's a smartphone-controlled small device. They are all developed by Sunburst. And the left one is lab on chip, and the right downside is from the USGS. I think it's an updated version of the DIY photometer from Boyang and me. And I think the Sunburst, the small photometer, has also been shown on also a GOA-ON webinar before. And for my research group, because we know nowadays people are relying on the smartphone, and the students, they want to do experiment. They just want to play with their smartphone. So I say, okay, I will give you smartphone for experiment. So 2 years ago, we developed a VC system called a versatile smartphone-based environmental analyzer, and to measure the nutrient first. We chose nutrient because before we are very familiar with the chemistry, and another reason is after adding reagent, the color could be very colorful. It can be pink, the red, the yellow, and the blue. So we have this new equation for the calculation between the color information and the concentration. So if our equation is universal, it can be used for different colors. So that's why we choose the nutrient for this. And the principle actually is very simple. You add the reagent to a sample, the color will change, depends on the chemistry and analyte you want to measure. And after that, you can put the colored solution in a box and take a picture. You get a picture, you can get the red, green, blue as a color information. And if you have some calibration curve, you will get the training data. And you can also use this calibration curve to get your concentration for the unknown sample. I think in the method A, you might be familiar, it's a spectrophotometric method. You should choose the maximum observation wavelength. But in the method B, you use the color space, use the RGB, the different information. So from this, we can get the data like for the 5 nutrients. We compare our data with the spectrophotometric data. They are pretty close to each other, and you can get a very good one-to-one line. The silicate is a little bit bad because we use the blue method, so the sensitivity is not very. It's the yellow silicate method. It's not a blue one, so the sensitivity is a kind of problem. And now in China, the WeChat is a very popular social media software. In different, no matter you use Apple, you use iPhone or the Android phone, you can use the same WeChat and the same mini program. So we have a WeChat mini program. We can measure the nitrite and ammonia because these 2 nutrients can change very quickly. So it needs on-site measurement. And we have this mini program and applied for the citizen scientist application. And when we come back to the pH measurement, we just published this paper last year with Todd Mars from Scripps. The principle is similar. We just add some pH indicator into the water. We use the methylcresol purple. It's a very popular indicator for the pH measurement. Then we take the picture. We are very lucky and very honored to give this as an analytical chemistry cover article for this work. So here, very fast. You can get the color change very fast and then take the photo. So it depends on the color, the information of the pH also the time, and also your location. So you can also send the information to a center, the data center, then you can we see the big data, right? If you have enough data. Here is a device. It's a 3D printed device, just like 20 centimeters long and 11 centimeters wide. And here is some figures for the device. We also compared the different phones that we can find in the lab, from different operation system. You can see the color of different phone, they are really different. But if you do the calibration curve in the same phone and also with a sample with the same phone, you can get very consistent data with different phones. So you will see the relationship is almost one-to-one correlation. So after that, we applied this for field application in a coral reef tank. In different tank, they have different coral reefs. Maybe Rachel, you know the biology very much, but I don't know. But in different tanks, the pH is different. We measure them on site and also collect samples and measure them in the lab with spectrophotometric method. So the data is very, very close between these two methods. We also did this like a walk and a measure. So along the Xiamen because it's an island. So along the seaside, we collect sample and do the experiment just near after we collect the sample. We have two cuvette, two bottles. One is a 10 centimeter bottle. The 10 centimeter cuvette is very similar like the benchtop spectrophotometric method. And the 2 centimeter is just a plastic bottle. It's very, very cheap. So we can also get very similar data with these two different cells. Here is a summary of the performance of these two systems. You can see with the 10 centimeter cuvette, you can get a precision even better than 0.00 something. So it's a very good precision data. And even with this 2 centimeter transparent bottle, a very, very cheap plastic one, you can still get a 0.02 precision. And the accuracy, I think, is acceptable for this low cost measurement. So, and this right shows the color in the 10 centimeter cuvette and also VC pH kit. We have a 3D printed device, a cell phone, and several bottles. And we use a dropper to add in the MCP, the indicator. So you don't need the pipette or the others. Just use a dropper to drop several drops of indicator. That's enough. So after the publication, I just found many people are very interested. So I got an interview from called Weibo. It's a kind of Chinese Twitter. So I got an interview. The people said, okay, you made a very good job, and it seems very magic, right? Use a smartphone to measure the nutrient and pH. But sorry for all of them are Chinese. And then I got an invitation to give a presentation in China Central Academy of Fine Art. It's an art university because they have an ocean sensors expedition. So during that one, our instrument, the VC, was invited to be exhibited in this art museum. That's the only one touchable art because the other arts are very, very expensive. You cannot touch them. But the art or VC can be used and touchable. So this thing is a very interesting art for this art museum. So we like to do this kind of outreach and education because the Xiamen University, we have a good research in marine science, environmental science, and ecology. And we also, I think the COSI China, the office of COSI China is also in Xiamen University. And we have the 70.8 marine media lab. It's a lab for the media. So we have a lot of programs for the education and outreach. And every year we have the annual Ocean Science Day. That's the most wonderful day of the campus. So just the last 2 weeks, our lab have a booth called the Magic Colorful World. So we use purple cabbage. So it has some isocyanidin inside, so the color will change at a different pH. So we have this color circle, and we have the small tubes with different materials, such as some soda, some vinegar, and some Sprite, and the others. So they are all safe to the kids, but they can choose a sample and add some reagent. So it's kind of magic for them to see different colors. So they come here and with different friends, different tubes, the color might be different. But before adding the indicator, they are the same. So they think it's very, very magic. And we also took our VC device, the smartphone device, and also a benchtop spectrophotometer there for different people. They might be interested in different techniques. So here I show some photos because it will be have to cover the face of many kids. It's very, very excited to see their small face. They focused on the experiment, and they really like to do this kind of experiment to know the pH change, to know the ocean acidification. So here are some examples, maybe just photo on the back. So no matter you are undergraduate student or just maybe 5 years student, they really like to use a phone to take the picture because it's very easy for them. And then they get the color information, then they know the pH, they think it's magic, then they really like to do this kind of the citizen science experiment. So after this science day, my student collect all the tubes and make this as a gift for me. You might see it's MG. The Ma Jian is a Chinese name or Chinese pronunciation is MG for me. So except for the citizen scientist, the real scientist, you might know Doug Wallace. He asked me about the details or VC, and just last month, we collaborated and submit a proposal as a seed fund to his university. So the title is Low-Cost Smartphone Analytical Technology for this community-based monitoring. And it can be used in the future, maybe for international capacity development. So in the abstract, he also highlighted that, okay, it's a colleague, it's me from Xiamen. We developed this technology, and they are trying to adapt this technology in Canada. And also we worked with 2 community organizations. So yeah, let's finger crossed, and I'm lucky if we can get some approved. So in the future, I think one is I will build more like a commercial apps, especially in different languages. Now it's in Chinese. And I think in the future, it's not only for this session, but for the OA week, because I noticed there is another session, it's technology gaps and for the OA research, because I know the president speakers, their work very well. So maybe in the future, I can get a chance to talk about the end-way pH analysis and also the in situ deep sea pH sensor. So the third one is because our method is simple enough. So not only the chemist, but also the biologist and the other ecologist, they can also use this simple method, especially now the marine carbon dioxide removal projects, they can also use our method. So at the last, I would like to thank the GOA-ON. So GOA-ON has 4 conferences. I went to all the 4 conferences, Science 2012, in Seattle, St. Andrews, Hobart, and Hangzhou. So finally, I got the chance to give a presentation for the OA week. And I'd like to thank the National Science Foundation of China and most of China. They support the work, and also Todd Mars for the VC project, especially my lab, the MG lab. My students, they did most of the work, and especially for Qian Fei and Xian Tao, they support their booth for the Open Science Day. So I will stop here, and thank you very much for listening. Thank you.
Thank you, Jian. It was a really interesting presentation, and certainly lots of potential for applications there, and your correlations with the spectrophotometer are incredible. It was really interesting to see.
Thank you.
Okay, thank you. So next I would like to introduce our second speaker, who is PB, a professor at the Indian Institute of Science, Education and Research, Kolkata in India. And he will present on the role of coastal communities in shaping ocean acidification monitoring in South Asia. And I've got PB's presentation to share. Perfect. Hopefully everyone can still see that. We can't hear you yet.
So the presentation, maybe there's some issue at my end, but anyway, I think I know the sequence of the slides, so I'll go ahead and request you to can move forward. Thank you so much for this opportunity. I'm going to talk about the how coastal communities who are marginalized globally, but they can play a very, very important role in effective monitoring of ocean acidification. And such exercises can help you run in shaping policies which can ultimately drive the
Oh no, I think we've lost him. Okay, perhaps while PB is doing some trouble. Oh, it looks like he's back.
Yep, I'm back. Thank you. Can you please move to the next slide? Sorry about that. Yeah, thank you so much, Rachel. So, as Rachel has pointed out before, the GOA-ON is very strategically placed because which started as a voluntary movement way back in 2012, now has really taken shape through the regional hubs spread across more than 114 countries. And this is a great opportunity because of many of these regional hubs are working very closely with the coastal communities, and we can harness the knowledge and the dedication of the coastal communities for effective OA monitoring. Next slide, please. This is extremely important because unless and until we have good OA data, we cannot have effective policies. And this has been also highlighted in the Ocean Acidification Research for Sustainability and even Ocean Decade Endos program, where you critically see that outcome one quality data, or for example, observing strategies have huge implications for outcome 6 and outcome 7. Therefore, we need to engage with the coastal communities more effectively, and it is great to listen to the last talk that how these handle instruments can be very, very important. Next slide, please. I'll give you one example from South Asia, where how the coastal communities are coming together to actually contribute towards effective OA monitoring and why this is important. Next slide, please. If you look globally, you will see that 40% of the global population resides within 100 kilometers of the coastlines, and they are on a daily basis facing the wrath of rising sea level, extreme weather events, and of course the invisible effects such as the ocean acidification, which we know this way week as helping to actually let the citizens and the global community know further about the impending effect of ocean acidification. Many of these coastal communities are represented by the indigenous and local communities. Their knowledge has been transferred from generation to generation, and we can harness the power of the knowledge and the huge resources they have towards monitoring of the climate extremes, including acidification in coastal ocean. This is extremely important because this knowledge can play a very, very important role in driving the local and regional policies, which can be ultimately linked to adaptation and mitigation. Next slide, please. I'll give you one example where how the coastal communities are driving the community-driven ocean acidification monitoring. And this is the map of the Sundarbans. Sundarbans actually is at the tip of the Bay of Bengal. It's the world's largest contiguous mangrove shared between India and Bangladesh. It's a very interesting mangrove system because it is one of the world's youngest mangrove system, which has evolved in presence of fresh water. It receives tide twice a day, and the tidal amplitude can be up to 7 meter. Uh, Huge freshwater flow of 40,000 cubic meter per second. Suspended particulate matter load is between 250 to 700 milligram per liter. So you can clearly see any sensors would not work out there. You really have to improvise local framework and develop strategies that can be implemented for community-driven OA monitoring. Now, the question is why this ecosystem is very, very important, because not only in terms of the endemic biodiversity, but also this is home to more than 2 million coastal communities whose daily livelihood are completely dependent on the rich bioresources that are there. And the Sundarbans, as well as the wider Bay of Bengal, supports the livelihood of more than 400 million people, encompassing more than 7 countries. Next slide, please. One of the beauty of working in this mangrove system is the presence of the swamp tiger. This is the only mangrove in the world where the swamp tiger is present. I wanted to highlight that any change in carbonate chemistry will also have huge implications of the existence of the swamp tiger. So it's not just communities, it's also a much wider scale, huge implication for this UNESCO World Heritage Site and beyond. Next slide, please. So in this kind of dynamic system, the land ocean boundary system, you really need to understand how the dynamics of the environmental variables and carbonate chemistry are before we can develop strategies for community-driven OA monitoring. So what we have done is over last 16 years, we have developed the Sundarbans Biological Observatory time series. This is an ecological time series where on a regular basis, we keep monitoring 40 environmental parameters, including biological parameters. For example, you can see the pH data, or for example, how the profiles of dissolved inorganic nitrogen changes, because these measurement of these oscillations are very, very important, as that would help shape up how the monitoring strategies to be driven by the communities are to be undertaken. Next slide, please. This is also strongly linked to another time series that we have called the Sundarban Seasonal Time Series. This is slightly different. What we were looking at was at the extreme left, the first time series, and now at the middle. These sites you can only monitor on certain times of the year. They have huge mangrove vegetation, but they hold huge bioresources. So any community-driven OE monitoring has to, have consequences, positive consequences for sustainable blue economy and livelihood in the long run. Next slide, please. So typically what we scientists do, we measure the carbonate chemistry, right? And we use very powerful tools, gadgets to do these measurements. So here's an example of how really the carbonate chemistry trend looks like in Sundarbans in presence of when there's variability in precipitation or cyclonic event, or typically the episodic oscillations where the system becomes a source and sink of CO2. So that's something which is very, very unusual. And then you have also the allochthonous carbon coming down from the freshwater that also drives this carbonate chemistry. So the dynamics of the system is very different. Naturally, during the summertime, you will get the pH which is naturally acidic. Okay, so you have to omit out the oscillations of the natural variability from the conditions of the ocean acidification. So a very dynamic system to work in. Next slide, please. So this is what we are doing, and coming down to the very important thing, that how do we monitor the OA to be driven by the coastal communities? one of the important thing is to develop the to do the capacity development, and in this capacity development is not an unidirectional exercise. It's also co-learning exercise essentially. So we learn from each other, from the communities. And here is one example where our fisherfolk communities are getting trained in measuring salinity. Okay, salinity is a very important parameter that can tell us in terms of space and time how the ocean acidification is developing. And we have shown many work in the past. You will see published in ESNT and other journals, the robustness of this approach. The second thing that's very important is that what are the best practices to be followed when you have to measure the coastal ocean health in keeping ocean acidification in mind. So we have also developed simplified user guide in different languages, regional languages, so that the communities can understand. It's not complex, it's in a very simple ways. They know how to use the gadget, how to do the calibration, and how to then transfer those data or store the data. Next slide, please. This is another example where we have taken this community-driven monitoring to a slightly different scale. One thing to keep in mind is that the monitoring has to be, activity has to be cheap, cost-effective, and sustainable, because the communities are giving their time, of course, because they care about the ecosystem and the environment. So on the left-hand side, you see a tide gauge has been put in. Tide gauge is a great way to understand really how the sea level is changing in the region. But also this tide gauge data can help us to understand over decadal scale or multi-decadal scale what the changes are happening. So the communities actually keep monitoring these tide gauge level data and record the data. What they also do is we have trained them to put the sensors for salinity and pH, which they regularly do calibration and validation. And then these data is getting transferred into a graphical user interface GUI platform on the right hand side bottom you're seeing, where the data is being stored, and then this data can be transferred subject to availability of the networks. So these data sets can store about 50,000 to 100,000 data points depending upon the time interval. So the communities know how much data, at what point the data is almost nearing full, how to take out that data, store the data, so that from time to time we can go and get access to the data if these monitoring is happening, let's say, in the remote part of the Sundarban. So this is entirely a community driven exercise that has been happening. If you look at the middle photo, top one, here you will see a classic example where the fishermen and fisherwomen have come together. They are actually planting the mangroves, but at the same time they are taking the baseline data for the salinity, for pH, and putting the sensors in the system. So it's a very interesting framework in place. And we must not forget that when they install these systems, they also take into account that the diurnal tides that are coming every day. So all these things are taken into consideration. The communities are being trained. Next slide, please. When you take those data, the community monitoring driven data, this is the kind of trends that you get. Look at the salinity, for example. We have more than a decadal scale salinity data, where now we are able to understand which are the natural oscillations and which are not the natural oscillations. So this kind of robust measurement is possible only when the communities are very actively involved, because they understand the system more than I do, at least as a scientist, or we do. The bottom one is another classic example where they have taken some of the basics of the OA monitoring and combined with the hydrology. For example, here you can clearly see that how the water level is going up and down during tidal regime or during the cyclonic events, and these data are being fed in, revalidated with the sensor data, for example, bottom right hand side, to see which data is to be taken and which data is not to be considered, because ultimately quality of data is extremely important if we have to effective policies. Next slide, please. Now I end up saying that this OA driven monitoring to be taken by the communities, and which are happening in many parts of the world, although maybe at a slow pace, but is gradually catching up. This is extremely important. If we are to have policy framework, we need to have the OA data, and only it's not simply possible for scientists to do that. You can do it for open ocean, put buoys, but the coastal ocean regions are far more dynamic and more vulnerable. So robust community-driven OA monitoring can ultimately shape the national policies, regional policies, which can then be interconnected with the regional frameworks and international frameworks. We have to keep in mind the extreme right-hand point that I have highlighted. time frame can vary locally and regionally. So co-development and co-learning exercise can vary regionally, but I think these hubs are a great way to actually learn from each other, just like we are learning from each other as part of this session. Next slide, please. I end up saying that the stakeholders are not only the coastal ocean countries or the coastal ocean communities. If we have effective OA monitoring to be driven by the coastal communities, the stakeholders would be also many of the communities who are living in the mountains and hills. For example, the Himalayan country of Nepal and Bhutan, where their livelihood, their culture, their ancient knowledge are completely dependent on the health of the coastal ocean. So we collectively need to drive this citizen science. We have the new technologies. We have to revalidate those based on cost effectiveness and depending upon local coastal ocean oceanographic conditions. And once we do that, the beneficiaries are are huge, spanning from below sea level to actually above sea level. So I end up here, and thank you so much for the opportunity to speak on this. Thank you.
Thank you, PB. That was really interesting. I thankfully I don't come across tigers in my intertidal fieldwork. I can imagine that's quite a hazard. Yeah. Okay, great. So I would like to introduce our next speaker, who is Hadija Udodo, a researcher and young ocean leader with the Sustainable Ocean Alliance in Tanzania, who will present on community-led restoration of seagrasses and mangroves in Bagamoyo, Tanzania.
Good morning, everyone. My name is Hadija Udodo. I have a degree in environmental sciences and management, and I'm working with Sustainable Ocean Alliance Tanzania, the official hub of Sustainable Ocean Alliance here in Tanzania. We are working to conserve the ocean by doing restoration activities, especially restoring mangrove and seagrasses, but we are working hand in hand with the local communities to restore the mangroves. Let me share my screen. Can you see it now?
I can just see the Zoom screen, not the PowerPoint yet.
Here, can you see?
I can see your screen, but not the presentation. You just need to flick tabs. All good.
Here, can you see? Can you see?
Yes.
Okay. Community-led restoration of seagrasses in mangrove in Bagamoyo, Tanzania. Let me start with introducing what is mangrove and seagrasses. Mangroves are a group of trees and shrubs that mainly grow in coastal areas. They grow in saline environment, salty water, and they can be found in subtropical and also in tropical regions. And here in Tanzania, they found in coastal region of Tanzania. Yeah, and in Tanzania, we have about only 10 species of mangroves, but there are about 80 species of mangrove worldwide. And seagrasses, a marine plant that's also known as lung of sea due to high capacity of producing oxygen gas. And also, these two plants are very crucial in mitigating the ocean acidification by removing carbon dioxide from the ocean and raising the pH of the water. And also, mangrove and seagrasses, they provide shelter to marine organisms, marine species, and also they act as carbon sink because they undergo photosynthesis. Hence, they use carbon dioxide to manufacture their food. However, due to human activities, mangrove and seagrasses are being rapidly degraded, leading to their loss. Like here in Tanzania, especially in coastal region, local communities, especially fishermen, they use mangroves as timber to build a canoe, as they believe that the timber from mangrove can sustain the salty water for a longer period of time compared to the timber from other trees that are not found in saline condition. And also they are building hotels in coastal areas, so for tourism activities, and they cut down mangroves in order to get area for building the recreation activities. And also fishermen here in Tanzania, they practice harmful fishing activities which disrupt seagrasses. And that is why in Bagamoyo, Tanzania, we engage local communities in restoring this lost ecosystem because they are the one responsible for degradation of this ecosystem from the start. And also we involve them because they have knowledge about the environment, they have knowledge about the area. Like in Bagamoyo, we are not the resident there. We go there in order to restore the degraded mangrove and seagrasses. But the local community there are the one that know the environment of that area. They know the activities they are doing there. And also by involving them, it will make them be the primal conservers of the restored areas, because if we do not involve them as we finish restoring and we left the area, they will continue degrading the seagrasses and mangroves. Like they will, after a period of time, as mangroves grow, they will continue to cut down them. And also this helps them to understand the process. By involving them, it helps them to understand the process and time it takes to fully restore mangrove and seagrasses, because this process is not easy. It's not an easy process to restore mangrove and seagrasses, especially seagrasses. It will require a lot of effort. It will require a lot of time, strength, and also commitment. And also for mangroves, like we have to create nurseries, and after a month we have to plant them, so it will require time and also it will require strength and commitment. So by involving the local community, they understand what we are going through for making restoration possible. And so by involving them, it will be hard for them also to degrade the things that they have spent much time to restore. Currently, we have trained and we are working with 30 local coastal community members in Bagamoyo, who also serve as ambassadors to their peer, neighbors, families, and other people who are found in Bagamoyo district in Tanzania. And we have chosen to work with 30 because we cannot work with all community members. Like, it is not easy to work with many people due to we have different preference and also to save time. Yes. And also during restoration, we work as one team. Like we do not like we work as one team regardless of race, income, religion, and status. And also we make sure that we work with local governments and other stakeholders, especially local government leaders found in Bagamoyo. We work with them and we make sure that we involve them in physical activities. They attend at the restoration field. They do all restoration activities so that we make everyone accountable. of the action. We make that like everyone to be involved, everyone to know the process, and to have knowledge in what we are doing, to have knowledge on how it takes to restore what we have degraded. And also to make these activities successful, we ensure that we have a teamwork. Like once we start, we do not like some are working and some are not. Like we work at one time, and if we want to rest, we rest at one time. And also we ensure that there is a space to everyone's opinion. Like we do have our knowledge about restoration, but local community members also have their knowledge on how they were doing restoration, like planting the mangroves. So we make sure that we ensure that everyone's opinion is being heard. Everyone has a space to speak, and at the end of the day, we come up with a conclusion of how we are doing this, the knowledge we incorporate. Yes. The restoration activities are full community led. Local guides the timing based on tidal patterns, like the restoration of seagrasses. We need to depend for local community members, which we are working on, and also local government found there. Like they tell that for seagrasses, it depends with low tide and high tide. So they tell us the time for low tide so that we can go for restoring seagrasses. And also they tell us like the days and months for low tides so that we can go and ensure that the process is going smoothly. And also, monitoring and protection of restored areas is easier as the community understands the challenges and has embraced the restoration as part of their daily activities. Like by involving them, monitoring of the restored areas will be easier. Like we will not be always busy. Like we have already involved some local community members. So we will be contacting local government and telling them that like they'll be doing monitoring to see how the restored area is doing, like if the mangrove have died, what is the causes, and how the seagrasses are doing. Yes. And also we they have also witnessed the benefits, including more fishes. Like these local communities members, especially women, they are doing some fisheries, small fishing practices. So, and seagrasses, it provides shelter for many marine marine species, and it provides shelters for many like seashell species, which these local communities, especially women, they take them to sell to the market to earn some income. And also, one of the benefits of restoring mangrove and seagrasses, it increased tourism and enhance carbon storage. Like there are some tourists who come to for swimming in order to see marine species, special fishes, and seagrasses. The seagrasses help in protecting the coral reefs. Beside reducing the ocean acidification, but also they protect the coral reefs, and also they enjoy the nice view for swimming for tourists, and hence it helps the local communities to earn some income. And also the carbon storage help in mitigating climate change, and not only the climate change of Bagamoyo region, but also it mitigates climate change of Tanzania and the world as whole, because they absorb the carbon dioxide for photosynthesis, for making their own food. And by working with local communities, up to now, we have been able to plant 18,000 mangroves in Bagamoyo, Tanzania. And also we have been able to adopt 3,000 hectares of mangrove area in Bagamoyo for restoration and monitoring. As you can see, this is the team, and also this is one of the local community leaders, the chairperson of the street. So we are working with them in installing, and this is for adapting the area for mangrove restoration has been easy because we involve local communities, and it has been easy. Like we go for all process to local governments, working with them hand in hand. So they provide for us an area for restoring the mangrove and also seagrasses. And also we have been able to adapt 0.5 square kilometer of an area for seagrasses restoration and monitoring, and collectively for both the seagrasses and mangroves that we have been able to restore up to now, we have been able to remove the 12,000 tons of carbon from the atmosphere. We must work as one to protect our ocean, which is the other lung of the earth, the aquatic lung of the earth, and we must protect in order to ensure that as the present generation, we enjoy our life on earth, and also for the future of the next generation. So we involve also the local community because we ensure that we know that the local community contain youth which are the parent for the future generation. So if we involve them during the restoration activities, they will have a story to tell for their children, and they will be able to teach their children on how to do restoration. They will be able to teach their children that it is not good to destroy the natural ecosystem, especially the mangrove and seagrasses, because it contains this and this importance to us. And also it will help to ensure that we are accountable for our own activities, because it's not easy. Like, we are going to restore mangroves in Bagamoyo. We are not residing there. We are not responsible for degradation. But by involving the local communities who are found in that area, they are responsible for restoration, so that like we hold them accountable in indirect way. So they restore what they have degraded. Thank you so much. And thank you for listening, and thank you for this opportunities to share with you on how we are doing restoration activities in Bagamoyo with local communities. As you can see here, it was in Bagamoyo last year. We were restoring seagrasses with the local communities members. Yes, thank you so much.
Thank you, Hadija. That was really interesting. I like the phrase you said, that they've embraced restoration as part of their daily lives, and I think we could all take a bit of that as well. So thank you very much for your presentation. Just a reminder that you can put questions in the question section or anything in the chat, and I'll pass it on to the presenters after for the question and answer session. So our final speaker is Azaria Pickering, who is a researcher with the Pacific community at the Pacific Islands Ocean Acidification Center, and she'll present on monitoring ocean acidification in the Pacific and experiences with the GOA-ON in a box. And I've got Azaria's presentation here to click through. Great. Hopefully everyone can see that one.
Yep.
Perfect.
Thank you for that introduction, Rachel, and thank you everyone for the beautiful presentation. My name is Azaria, as Rachel introduced, and I'll be speaking on the experiences with GOA-ON in a box. Next slide, please. So briefly, we know that OA is a direct result of increased carbon dioxide emissions into the atmosphere that gets absorbed into our oceans. And so understanding this process and its impact on marine resources and ecosystem services is vital for us, particularly here in the Pacific, where we have a heavy dependence on the ocean for food and economic reasons, but it also has traditional and cultural significance. So looking at what's available at the various levels in terms of the reports or commitments to OA from national, regional, and international levels, we have the SDG 14.3.1 indicator, which is aimed at reducing ocean acidification. We also have the indicator portal where all OA-related data is uploaded and has open access. We have the annual COP, Conference of the Party. Last year they had almost, I believe, 30 side events covering blue carbon, one of which focused on ocean stress. And they highlighted ocean acidification. We also have the Global Ocean Observing Network and the Ocean Acidification Research for Sustainability, promoting ocean literacy on impacts of ocean acidification and ocean health. We also have the climate change sixth assessment report that talks about OA impacts on food production from fisheries and shellfish aquaculture. And they also state that OA is one of the processes causing ecosystems to approach irreversibility. Yep, we have the State of the Ocean report that highlights the need to understand local and regional variations in OA. It also has a section on the status and trends of OA. So it shows the mean global increase in ocean acidification for all ocean basins and seas. At the regional level, we have the Aotearoa hub. That's part of the Global Ocean Acidification Observing Network. And we also have the Pacific Islands Ocean Acidification Center, which comprises of countries that have received the GOA-ON kits for collecting weather quality OA data. And this is through support from the Ocean Foundation under their Ocean Science Equity Initiative. At the national level, we have national ocean policies that acknowledge OA as a climate change impact. Fiji, for example, is going to go through a review next year, and they're looking to elevate OA in the national ocean policy. But in general, we have ocean acidification highlighted in almost every climate change or ocean-related talk. Next slide, please. So we see commitments at all levels, but there's a lack of capacity, and resources need to be invested into the Pacific to enable, sustainable monitoring programs. And if they exist, they do need support for long-term investment. So if we look at the regional experience and needs assessment for the kits, for the GOA-ON in a box kits that are distributed in the Pacific, we have 9 countries that are part of the Pacific Islands Ocean Acidification Center, which is a regional hub that was established back in 2022 to provide OA research and technical support. Again, I just mentioned, as I mentioned, this is through the Ocean Science Equity Initiative. And so on my slide, you can see the number of kits received per country, and as part of their needs assessment, I've also highlighted the countries that have a mercury filtration kit and those that don't, as well as those that those that don't have a full kit, for example, Tokelau and Kiribati. Yeah. So Fiji received 2 kits. One was used to collect data. That data can be found on the SDG portal, and they started their monitoring program last year in February, and it's active right now. Vanuatu also received their kit back in 2018, which they used to collect data. That data is hasn't been uploaded yet, but and it needs to go through quality control before it's submitted to the portal. We have Solomon Islands that received the kit as well. Unfortunately, some parts of their kit did not make it to the full shipment. So the center is working to support them with these missing parts to allow them to have a full kit. So these are also the countries that attended a hands-on training last year. And so as part of the center's role to provide support, we're looking to host another training so that the countries can start collecting data. Next slide, please. So this is what's included in the kits. You can also find a full list on the GOA-ON website. We have equipment for deployment. We have a pH sensor. We have the CTG. Some of these equipment used in the field, the GPS and salinity band. We also have those for discrete water sampling, pH measurements, total alkalinity measurements, as well as the mercury filtration kit. I just want to highlight that the kit was just recently introduced. For previous kit recipients, back in 2018 when they received their kit, this was not included in the kits. So now having this included allows the countries to manage their mercury waste. Next slide, please. And this is an example of the data collected or what the kit can be used to collect. And this is an example from Fiji. To my right, we have a picture of one of the scientists collecting discrete water samples. At the bottom, we have a temperature time series from the CTD, and you can observe a seasonal difference in sea surface temperature. So this is between September this year and February 2023 till September 2024. And then the top graph is the pH corrected with salinity measurements, and that's used through that's collected from the ISAMI and processed through the QCPH program that's available on through Sunbest. Next slide, please. In terms of challenges, and this is cross-cutting across the region for those that have the GOA-ON in a box kit. So some of the challenges we faced is equipment breakdown and the lack of training support after receiving the kits. There's a difficulty in accessing or ordering the spare parts. There's limited support for ongoing training needs and assistance and maintenance of equipment. We've observed a high staff turnover, particularly those that receive the training. And so, when they leave, this results in inactive kits and monitoring is discontinued. There's quality on data, quality control on data management and submission. The lack of funding for ongoing monitoring, staff time, and equipment replacement. We have institutional space, for example, in Tokelau and Tuvalu, where land is this land space is it's small and they don't have the institutional space or capacity for programs as such. And the lack of collaborative support or monitoring can be quite technical by themselves. And here in the Pacific, we are often isolated and we don't have the resources to do the work by ourselves. So this is a real need for support. Using mercury chloride, like I mentioned previously, there were no filtration kits. and also the absence of legislative frameworks governing the application and the management of mercury, at least at the national level, is a major challenge for us in the Pacific. And I've also a limited capacity for the ISAMI maintenance and troubleshooting. So this is going back to the pH sensor that's included in the kit. Next slide, please. And these are some of the solutions moving forward. The center plans to have individuals receive technical training in ISAMI repair and maintenance. And this was done earlier this year, where we had staff from the center travel to Hawaii to receive training. And so the center aims to extend this support to the countries that needs this service, because initially having the equipment breakdown was a major challenge. And the center also received a shipment of spare parts, and so this is used to service the GOA-ON kits in the region, particularly those kits that need pieces of equipment replaced. However, to continue providing these kind of services, we have to ensure that there's proper funding in place, and funding, because the funding allows for these services to continue. When conducting trainings, hands-on and technical support is key. So we plan to have in-country trainings to support the countries from setting up the equipment, running it, staff turnover. Now this one's out of our control, but to ensure that we have maximized capacity, we plan to have in-country training, and to extend the audience to include others, maybe junior scientists or university students, so that they can continue or take over. And yeah, because in our previous trainings, we've only had like 1 to 2 people. So having a wider audience is one of the solutions that we have to this challenge. And in terms of quality control and data management, this is one that's easily addressed once the countries have started collecting their data. And it can be supported through the practical best practices guide that's published on the website, the PubPub website that's available now. We also plan to put together a proposal to pitch to potential donors, and this is for the running the center and for the sustainable future of the center. In terms of institutional space, this is where collaboration between institutions come into play. And for my last point on the mercury, the previous slide, we conducted a preliminary study to understand the regulations in place for each of the countries for the use and disposal of hazardous substances such as mercury. And so this is the work that's still in the making. Next slide, please. And these are quotes from trainees that attended the 2023 hands-on training last year using the GOA-ON in a Box kit. And so, yeah, our question was, how do they benefit from the training? And that was our response from Tuvalu and the attendees from Vanuatu. Next slide, please. Yeah. Well, thank you, everyone. I just want to thank you for your time, staying back to watch my presentation. And I'd just like to thank our project partners, the University of the South Pacific, NIWA, University of Otago, Pacific Community, and our collaborative partners, NOAA and the Ocean Foundation. Thank you.
Thank you, Azaria. Great presentation. It's interesting to hear about the additional considerations, such as the use of the mercuric chloride, and having to introduce additional kind of legislation and strategies for that. Thank you very much. That was really interesting. So thank you to all of our speakers. I'd now like to open the floor to any questions from the audience. So you can either type your questions into the Q&A box, which is found down the bottom of Zoom, or you can raise your hand and ask your question directly. I have a question for the speakers before we put them to the floor, if they're only going to pop up. So Jian, I really liked your comparison of the measurements with your phone apps with the spectrophotometer, and that correlation was really incredible. I pay so much for nutrient analysis and pH analysis and things like that here at NIWA, and I'm just wondering if you find that when your students and other community users of the method and the app run their samples, do you get kind of similarly good correlations with the spectrophotometer? Have you measured that?
Thank you for the question. I think our collaborator Thomas, he said he would, because he also taught how to measure pH in Seagrasses. So he said he would like to build a VC for his student and especially for undergraduate student. But I'm not sure if he had done this. And like I showed in the slides, that we submitted a proposal with DOC, and if it has been proved, we will build the VC for the Canadian local community for this. And because my students, Hang Qian Li, she made this kind of experiment. So now she's in GOA-ON, and I also asked the other students to repeat this kind of experiment. We also recruit 2 undergraduate students. They have very limited training, but after like 20 minutes introduction for this, we ask them to do the similar experiment. I will say the precision depends on if you are very familiar with this operation, but we can still get like a precision for the pH could be 0.01 or 2. That's easy data we can get. And for the nutrient analysis, if the concentration is not very low, we can get like 5% difference between the VC and the spectrophotometer. But yeah, it's not very sensitive. So the concentration cannot be low, because if you cannot see it with your naked eyes, maybe when you take the picture, and also the background light has some effect on the picture. So that's why we put them in a box and control the light. Now we are working on another algorithm to compensate for the light difference between these, but it's difficult. It's very difficult.
Yeah, it's cool though. I want to have a go. Awesome. I've also got a question for Hadija. You mentioned that the community is also causing the degradation of the mangroves by harvesting the wood to build boats and hotels and things. Do you find that after you've got the community individuals involved in restoration, that they then in turn change their behavior and cause less degradation and harm to the mangroves and seagrass areas?
Yes, as we involve them, it has led to less degradation of mangroves. Like, it is not completely not being done, but it is less degradation. And for the area that we are restoring, it is protected by the local government, because we have involved local government and also the local members local community member we are working with, they act as ambassadors for monitoring and protecting the areas that we are restoring. Like we have given a portion of land in the coastal area. Like for the seagrasses, it's a portion of the beach where we are restoring. And in that area, no activities are being conducted. Like fishing, fishermen are not allowed to enter in that area, and it is being protected by marine conservation and local government and the local community. So for the area we are protecting, we are restoring, there's no degradation. And also, like, there's no degradation because the mangrove are still small. So we look into it when the mangrove grow bigger. If there's any degradation, yeah, we will note it. Thank you.
Yeah, a really long-term project, and really interesting to hear about. So I guess maybe we've got time for one more question, because we're approaching 7:30 and I don't want to keep everyone. So I just had a question for Azaria as well. So it seems like there's a lot of challenges getting the data from the Pacific, and I guess the GOA-ON in a box, while they're not hugely expensive, it's still like very specialist kit, and you've still got to get it out to the Pacific. Do you think the main limiting factor for getting more data is getting more equipment and more GOA-ON in a box kits out there, or do you think it's getting personnel trained and able to get on the ground and take the measurements?
Thank you for your question, Rachel. I think it's big. I think the most important thing is, after countries receive the training, it's that follow-up after training, that support that's needed. It's easy to receive a training, but then like for you to go back to your home country and then try and start up the program using this whole new kit, that can be a big challenge personally, because I've used the kit. And for most of these countries that received the training last year, the new kit recipients, at least, they've only started receiving their kits this year. So, there's a lapse of 1 year. And so there's that need to have that support to conduct the in-country trainings and to provide the support that they need to get their monitoring programs set up, and to have that comfortability and confidence with using their kit. So thank you for your question. I hope I answered it well.
Yeah, all good. Thank you very much. Great. So I just want to say thank you to all the speakers for their enthusiasm and their really interesting talks. I also want to thank the sponsors and the organizers of GOA-ON Week. And thank you to those of you online who joined us for this session. Don't forget to look at the website and to register for any other sessions that might interest you. If you'd like to stay up to date with more GOA-ON community happenings, please consider signing up as a GOA-ON member and keep your eye on our social media sites. So thank you, everyone, and hopefully see you next time. There's loads more sessions today, so and for the rest of the week, so please join us. Thanks, everybody.
Thanks,
Thank you.
Rachel.
Thank you. Bye-bye.